Okay, we're gonna do the respiratory system today, and the third assessments are up until the 11th. Okay, so breathing, it's a good idea. This has been a topic near and dear. Well, I don't know whether it's dear, but I had pulmonary effusion this year where I had fluid on my lungs. Uh, so that was an adventure. So the lungs didn't like the fluid. Okay, so components of the respiratory system. So nasal conchae are there to allow air to swirl around to warm the air. The nasopharynx is the first part uh, of the respiratory system. So you'll have some questions about these. The respiratory system depends upon very close contact between the blood and the air that comes into the alveoli, and also the CO2 that leaves the blood vessels to get into the alveoli to be expired when you get rid of CO2 when you take a breath out. So we look a little closer. So here we have the frontal sinus. Who knows what sinuses are for? Nasal cavities. Uh, the nasal pharynx right behind the nasal cavities. The external nares, which is the opening of the nostrils. Uh, the nasal cavity and nasal pharynx sit right on top of the hard palate. Then we have the oral cavity. So you'll have questions on WebAssign. You just got to be able to identify these structures. The respiratory epithelium uh, in the trachea is ciliated columnar. So there's cilia, there's mucus secreted, and everybody knows if it's a very hot, dusty day, perhaps you may have to expectorate some mucus, and it often will be full of dirt. So the respiratory epithelium, as we say, is full of cilia. This is a colorized picture of cilia. So here's our cilia here. Its purpose is to, with the mucus, to catch dirt and other detritus and get it out of the body. If we look at the larynx and vocal cords, we have the epiglottis, which keeps food and materials out of the trachea, the thyroid cartilage, the cricoid cartilage, and the tracheal cartilages that go around the trachea and help keep it open. Look at the posterior view. There's the epiglottis. The thyroid glottis is in front of it, and then the voice box with the false vocal cords and the vocal cords. So that's where we're able to generate speech, which is a good idea. It seems to be a good idea up until now, up until COVID and with the political stratifications in the country. Amen. So we looked at the larynx, and we can see the anterior view and the posterior view. We won't have we won't have any questions on this. The questions will focus on the right here, focus here. So if we look at an actual view of the vocal cords in the epiglottis, which function is to keep material out of the trachea. Everybody knows that sometimes we get fluid or solids into the past the glottis, so we have a coughing reflex to get rid of that. The trachea, its whole purpose is to convey air through the larynx into the trachea and split into the secondary bronchi after the primary bronchi. And you can see that the tracheal cartilage is there to keep the trachea open, and the esophagus is right next to the trachea. Obviously, esophagus is for food moving into the digestive system, the trachea able to get oxygen and get rid of CO2. The primary bronchi, the primary bronchus, that's continuing branching until the terminal bronchi and the respiratory bronchiole get into the alveoli. The alveoli are fine sacs that allow exchange of gases between the blood and the alveolar sacs. Don't smoke, it messes up your alveoli. That's not a good idea. So the fine structure of the lobules are these accumulations of alveolar sacs. The lung is surrounded by parietal pleural, the pleural cavity, and the visceral pleural. So the lung has an entire external covering that allows the lungs to move and to protect the lung, and also attach the lung to the body cavity so that the lung can expand and then recoil back to its position so that air can be eliminated through expiration. So the bronchi are surrounded by smooth muscle. Anybody that has asthma knows that the function of the smooth muscle is very, very important. So we got somebody coming in, admit, okay. So we're back to the PowerPoint. So all I want you to know that the trachea divides into smaller and smaller tubes to bring air to the alveoli, where exchange between the alveoli and the blood takes place. The alveoli are very, very numerous and surrounded by elastic fibers to help keep them open. When newborns are born too early, sometimes there can be problems with surfactants, which help keep the alveolar sacs open, and young neonates, new babies that may be premature, have to be treated with surfactant to help keep the alveolar sacs open. You can look at an scanning electron micrograph of the cavities. They're very, very small sacs, and they're very, very numerous. Their whole purpose is exchange CO2 to get rid of CO2 from the blood, and to pick up oxygen moved into the blood. There are macrophages in the lungs, which are there to consume waste and detritus and little bits of dead cells. Each alveolus is lined by flat squamous epithelium. Notice how the blood vessels are very, very much in evidence, and they are very, very numerous. And notice how the thin layers of the cells surrounding the alveolar sacs are very, very allow for exchange of gases. So here's a red blood cell. Here's the alveolar alveolar airspace, and you have to have a surfactant to make sure that the alveolar sacs stay open, because surface tension of the moisture in there can cause the sacs to compress, and that destroys the whole purpose of the alveolar sacs and the alveoli to get oxygen to the blood and to get CO2 out into the alveoli so that the CO2 can be expired. Notice how these endothelium and a fused membrane, and with the very, very thin covering of the alveoli. They're both very, very thin cells, squamous epithelium. So red blood cells want to get rid of CO2, and CO2 is also dissolved in the plasma, and oxygen is carried primarily in the red blood cells when it moves out of the alveolar sacs into the red blood cells. The right and left side of the lungs are slightly different. We won't ask any questions about that. So let's move through that. Let's go ahead and stop this a moment and go back here. Stop recording. Stop recording.